Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. Knowledge is power, now more than ever.
And hello, everybody. You are very welcome to a new episode of Redefining Cybersecurity here on ITSP Magazine Podcast Network. I am Sean Martin, your host of the show, where I get to talk about. I don't actually get to put fingers on keyboards too much in a practitioner sense, but I get to talk to a lot of people who do get to talk to and do this work out in the field with the ultimate goal of operationalizing technology and security in a way that not only protects the business value, but helps hopefully generate some value as well. I think I do truly believe there's an opportunity for that. And so today's conversation, we're going to it's driven by a book that actually my co-founder already had a chat about. It's called Wiring the Winning Organization. And there are two authors for this, Stephen J. Spear, who Marco had the chance and pleasure of speaking with, and a longtime friend and peer, I should say, in the industry, Gene Kim. Gene, it's a pleasure to have you on the show.
Sean, it's so good to be talking to you. And we were talking before the show, and I think it's been 20 plus years since we first met.
It explains
sand circles, RSA circles. Yeah.
Exactly. Yeah, definitely conference circles. It goes back to a lot of mutual friends that ran in circles with me at Symantec and crossed paths, obviously, with the work you did at Tripwire, and it's great to be connected with you still after all these years. So a few days have passed.
And years and decades. That's amazing.
Years and decades. Congrats on all the amazing things that you've done, and I know one of your earlier books it's definitely a huge hit and continues to be a resource for many folks. I continue to hear that. So congratulations on that. We're going to be talking about your current book. That's available to folks, if I'm not mistaken. But before we get there, I'd like maybe for you to paint a picture of your journey into infosecurity. Maybe touch on a bit about what Tripwire did and some of the things that were revolutionary in those days, as you brought that organization and that team to life, and then from there, some of the other things you've been involved with to bring us up to date at least, and then I suspect we'll use it to kind of figure out what has changed in our lives from a technology and threat perspective.
For sure. Yeah. In fact, maybe I can rewind. Let's start from the beginning. Like, how did I get into information security? And the answer starts when I was in high school. It was 1987. I was actually working part-time as a system administrator at Prisma Supercomputers, which eventually got bought by Sun Microsystems. And this was around the time of the Internet Morse worm that hit on November 2nd, 1988. And I think anyone who's doing sysadmin work or information security will remember that, because 10% of all the servers on the internet were taken down by this remote execution vulnerability. And it couldn't. So I was applying for colleges, and the person who was doing the most amount of writing on this was Dr. Gene Spafford at Purdue University. And so I ended up going there for my undergraduate. Did an independent study with him, and this is actually what eventually ran into a project that our goal was, all right, how do you sort of detect and ideally prevent these things from happening and enable quicker detection and recovery? And that was really the birth of the tool that eventually became Tripwire. And after I left Purdue, I went to University of Arizona, where I got my master's degree in compilers and networking, and we created a startup to help commercialize Tripwire in 1997. So I was there for 13 years. I was the technical co-founder. I was the CTO, and I left in 2010, right before it was right after we finished our filing to go public. And even though Tripwire didn't make it to the public markets, I mean, it was I'm so grateful for that experience. And so after I left Tripwire, I spent 3 years finishing a book called The Phoenix Project, which was a novel about a reluctant VP of operations who had to deal with terrible code that was never really tested before it got pushed into production, was never secured. It was just it was modeled after one of my favorite books called The Goal. That was that was written in 1986. It was a novel about a manufacturing plant manager who had to fix his cost and due date issues in 90 days. Otherwise, it would shut the plant down. And so my co-authors and I, for almost 15 years, we wanted to write essentially The Goal, but for the IT context. And one of my favorite characters in that book is not the protagonist, who's the kind of the VP of IT operations, but John, the Chief Information Security Officer, who was really kind of a caricature of myself. He was the shrill, hysterical person who was focused on technical minutia that everyone despised, ignored, and it has this kind of transformation that as he realizes that he needs to shift left, integrate into the daily work of development, QA, operations, and really help kind of advance the goals of the organization, the business. And so that came out in 2013, and that sold almost a million copies since then. And so I'm just so delighted that's really been adopted as a kind of like a banner of like around the DevOps community. And so that's been my field of study for at least 15 years. This really kind of a subset of the 23-year journey studying high-performing technology organizations, that had the best project due date performance and development, they had best operational reliability and stability in ops, but they also had the best posture of security and compliance. And so that's a journey that took me into the DevOps movement. Since 2014, I've been running a conference called the DevOps Enterprise Summit, studying not so much the tech giants, the Facebook, Amazon, Netflix, Google's, Microsoft's, but instead large, complex organizations that have been around for decades or centuries, and showing that they've been using those same principles and patterns, and using it to help their organizations win. And we recently renamed it the Enterprise Technology Leadership Summit because it's not just dev and ops; it's dev and ops and security, and and the business and the product owners, and things like generative AI, platform engineering. So it's just same programming, but many people thought that we had sort of outgrown that name. So that we've had 19 conferences, over 1,100 technology leaders across some of the best known industry verticals. And so just to wrap up, I mean, what I've been working on for the last 3 years is working on this book called Wiring the Winning Organization. My co-author is Dr. Stephen Spear, who pioneered the study of the Toyota production system. So he wrote the famous Decoding the DNA of the Toyota Production System. That's the 1999 Harvard Business Review article, probably the most widely downloaded Harvard Business Review article of all time. And so he extended that work beyond just manufacturing, but to engine design and Pratt & Whitney, to helping build a safety culture at Alcoa. And the quest we've been on for the last 3.5 years is, what is in common between Agile and DevOps and safety culture and Toyota Production System and Lean? And our conclusion is that they are all incomplete expressions of a far greater whole, but it's actually one that's very simple to explain. And so I just, it's been the most intellectually challenging thing I've ever worked on, but also one of the most rewarding because it can, I think, help us explain, why does DevOps work? Why do organizations work the way they do? How is it that, what must information security do to truly integrate into the work of everyone in the technology value stream? Anyway, Sean, how am I doing here so far?
This is fantastic. I mean, it's fantastic. My brain's going a mile a minute here. Yeah, because I think if we look back, it was networks and applications, right? and a few different operating systems, and things have just blown up. I mean, you have multiple operating systems, some of them on devices local, a lot of them in what's called the cloud now, and there's abstraction layers and containers and virtualization and all kinds of stuff in there, and APIs to connect them all together. And all that I just described is kind of the tech piece. And then you pointed out that there's also the culture, right?
Yeah.
And oh yeah, there's also the business. What are we doing this for? Not just because we can or because it's cool, right?
Yep.
We're doing this for a reason. And oh yeah, by the way, we need to have high quality and good performance and security, which connects the other two as well. And even as you're describing your journey, and as I'm kind of putting out a few words here, even if not in connected form, it, it's become really complex. So I'm intrigued by how you approach this um, in a way, because you said it's simple.
Yeah.
To me it's complex. Having I'm not recently, been back in the day. I used to build stuff, used to QA stuff, used to run teams, used to run products, and those were challenging. Right, bringing a product to
Yeah.
market, it's challenging. Small or large, challenging. Enterprise, super complex. So how do you simplify
Yeah.
what
And
we're trying to talk about here?
I love the I love there's a saying that says anyone can make something simple appear complex. It takes it's a different
I
problem
just did
entirely to take something
that.
complex and make it look simple. And I'll just share kind of three kind of huge aha moments I've had over the last 2 decades that really kind of in the last 3 years just came to searing aha moments. So one of them is the notion that in almost every domain, whether it's software, whether it's manufacturing, whether it's engine design, whether it's in military operations, one of the key problems is managing the socio part of the socio technical system. And so um, and there's actually so much in common. In fact, I think what's exciting about this work with Dr. Steven Spear is we're saying the same sort of engineering sensibilities that we use, design and manage the technical parts of the system, we can also use to manage and understand the socio parts of the socio-technical system. They call that sort of layer 3. Layer 1 is the object being worked on, whether it's the code, the application, the part being assembled, whether it's the engine being designed. Layer 2 is the tools that we use, but layer 3 is the social circuitry. And we use the word circuit very deliberately because a circuit in an electrical system, in hydraulics, is always taking something in abundance in one place and delivering it to where it's needed. And so, in the ideal, everyone has what they need when they need it. They're talking to who they need to get it at the right time, the right place, in the right format. In the not ideal, and this is so much of what went wrong in the Phoenix project, is no one has what they need, right? They have to scavenge and forage for what they need to get information rights, approvals, decision rights, requirements, code, license keys. No one can get anything done, and even when they do, it's not at the right time, in the right place, in the right format. And so, and that is all a function of the social circuitry. The second, I think, really big insight for me was that I learned that managing hospitals was actually much simpler 70 years ago because there were essentially two functional specialties. You had the doctors and the nurses, and there was really no technology. And compare that to now, you have scores of functional specialties just in doctors, right? Let alone nurses, supply chains, pharmacy, etc. Right? In fact, the radiology department is actually now 4 separate technologies, which all have the layer 2 and layer 1 work. I mean, so the amount of communication coordination is so sadly, right, often outstrips the ability for the layer 3 social circuitry to actually work, which is why it's so awful often to be in a healthcare setting. And so you take a look at technology, like before maybe 70 years ago, right? We didn't have dev and ops. You had just the devs who were responsible for operations. Now you have dev, ops, security. You have containers. You have platforms. You have all these things, right? And so this explains, I think, why it's so increasingly challenging, to manage, these very complex socio-technical systems. And I think that the third thing is that shifting left is right. In fact, one of the metaphors we use in the book that I'm just so proud of is is we're saying so much of knowledge work is like moving a couch. So you have two people moving a couch. Let's call them Steve and Gene, and you would think that this is all brawn work, no thinking needed, and yet for them to move a couch, there's actually all these problems they need to solve. Like, where's the center of gravity? Around which axis do you rotate to get through a narrow doorway, to get through a narrow winding staircase? Who goes first? Should they face forwards or backwards? And you don't need consultants. You don't need focus groups, right? Just by picking up the couch and trial and error, fast feedback, Steve and Gene will be able to figure out how to, achieve the goal. But there's all these things that we as leaders can do to make it far more difficult. Like we can turn off all the lights, right? And it gets more dangerous, takes longer. We can damage the furniture and the room. We can introduce a lot of background noise, like a siren, and or we can introduce an intermediary preventing Steve and Gene from directly talking to each other. So they can't communicate and coordinate. And so they can no longer operate as a team. So instead, we make them go through JIRA tickets, or we have them go through complex approval processes through the GRC systems. And so it means that they can no longer communicate and coordinate and solve a problem together. And so the metaphor of the couch is really around joint cognition, joint problem solving. I think the reason why shifting left has been such a breakthrough. Well, first, allowing dev and ops to work together and move a couch together is what created these amazing outcomes where you can, organizations like Amazon, they do 136,000 deployments per day safely, securely, with reliability, because we have them actually talking to each other, right, and moving a couch together. Where does information security fit in? It's that before, the information security person had to help move the couch. So they had to be there for every couch moving operations, and there's just not enough of us. And so what does security really need to do? They create tools so that Steve and Gene can do the work independently, right? So that, security can create these, paved roads that, if you, I'm sort of mixing metaphors here, but as long as, developers use that paved road to get in production, they can be the first line of defense, right? Because they will own 80, 90% of the control requirements, liberating the developers to worry about things that only they can do. So anyway, how am I doing here?
Yeah, I love those 3 points, and it reminds me of, so many things we can talk about. But just yesterday, I had to go to the dentist for
Me too.
for
2 days
for,
ago.
for something that was going on with the tooth, and I arrive, and they said that we didn't allocate enough time for your appointment because we need to do all this work. And I said, no, you've already done that work and it didn't work, which is why I'm back. And it was this weird, it goes to your point of giving the right information at the right time for who needs it. And there was this multiple exchange between the front desk and the doctor and then myself,
Yeah.
sorting out that no, the work didn't need to be done because it had been done. Which very inefficient, right? If the doctor had actually set up for that procedure and pulled all the materials, could be a lot of waste. And of course, my experience as the customer,
Yeah.
I don't really care. I mean, it all got sorted out in the end, but not a great experience for the customer either. So not having the information ready at the right time can have a huge impact on the outcome of what you're trying to achieve. And the other thing that I want to point to is the just the moving the couch. And I think you described it as a bit of trial and error, right? Will it go up the stairs and through the landings and through the doorway? You can try, or you could bring somebody like security in or quality assurance in and say, here's what you can expect, right? Let's do that math.
Yeah.
Let's run through those scenarios before we even try, so that we don't, either before we release or in front of the customer,
Yeah.
run into this problem. And so I'll leave it there for you. So
No,
your
I love
thoughts on
that. In fact, I think you've really picked up on like what when we're saying that there's really 3 mechanisms of performance. And maybe just to set this up a little bit, just to maybe describe adequately just how much of an aha moment this is. Many of you might know that I spent one of the things I'm most professionally proud of is working on something called the State of DevOps Research. This was with Dr. Nicole Forsgren and Jez Humble. It was this cross-population study that spanned over 36,000 respondents over 6 years. And the goal was really understand, what does high performance look like? And so it was just amazing. These high performers doing multiple deployments per day. The amount of time required to go from code committed to running in production was 1 hour or less. When things went wrong, they could fix it in, again, 1 hour or less. And this is like 2 or 3 orders of magnitude better than their peers. And so the top 2 predictors of performance one was architecture, which was, to what degree can teams work independently of each other without a lot of fine-grained communication and coordination. And when something goes wrong, does it cause a small failure or a big failure? We often call that the blast radius. And the second thing that was the top predictor of performance was was the presence of like psychological safety. And so so whenever we see, these amazing transformations from from not high performing to high performing in technology, if you look at something similar in manufacturing, in engineering, you actually see something very, very similar at work. And what we're saying is there's really only three mechanisms of performance to go from, not great to great. And so it's basically three things. One is slowification. In other words, there are certain things you should do when you are working in highly consequential environments where you can't undo, that have kind of enormous outage cost. You can't learn, and under those conditions, you can't learn, right? You can't do a lot of experiments. So therefore, you have to do that in planning and preparation. So whenever you see something, someone doing some splendid, exquisite work in highly consequential environments, you just know that they invested in planning and preparation. And so we see that things like that in like Chaos Monkey, right? We test and inject faults into the production environment to see if we are as resilient as we think we are. You can see that in like consequential military operations, and so forth. Right, planning and preparation, right, is where you learn, not production. Production is where you learn, but it's better to learn it in these kind of safer environments where it's slower. We can have more control. We can iterate and so forth. The second mechanism of performance is simplification. Make the problems easier to solve. So we do that by solving problems either incrementally, so that's like agile, like lean startup and so forth, right? We don't solve the whole problem at once. We solve them in slices. The second is that we split the problems up so that instead of one large, interconnected, highly intertwined, highly coupled system, right, we divide up into smaller pieces. So that's like the Amazon 2001 transformation, where they went from one code base that all had to deploy at the same time to hundreds of them. So that's what allows them to do 136,000 deployments per day. And then the orthogonal one is linearization. We do the same thing, but for linear sequential processes. And it creates this independence of action that allows teams to work independently of each other, to improve independently of each other. And then the last mechanism, we had slowification, simplification, and then amplification. We have to amplify weak signals of failure so we can act upon them decisively, before they become huge failures, right? And so we can better prevent, detect, and correct. And I think for information security, right, it's so important that we detect these weak signals of failure, so that we can fix them before it gets into production, right? We can so we can train engineers, we can improve and harden the environments, or create better CI/CD pipelines to deploy code into promotion. We can increase the telemetry, because again, we want to be able to take every one of these weak signals, right, and act on them so that we can better achieve our most important goals. And so your slowification, one example I love, right? Before we actually do the staircase operation, maybe we should walk it, walk the path with
Exactly.
someone who has a lot of experience doing it, right? Like our information security peers. So we have a better shot of not having to see it for the first time in production.
Yeah.
How am I doing?
Yeah. So I love it, Gene. I mean, I geek out on this stuff anyway, so it's fantastic. How Let's stick with the area that you've been most involved with over the past few years, in the DevOps. So we can use let's pull on some examples there. What I'm trying to understand is, let's start with team structure, and then maybe
Yeah.
we can move into some of the processes. Because
Mhm.
what you're describing, um, you touched on it earlier in the context of specialization, right? Looking at the doctor's or the hospital, there's a ton of specialization, which leads me to believe perhaps we need specialization in DevOps as well. So how does this fit, or how do you apply what you're learning directly to DevOps? And maybe we can blow it out to the bigger security program to help some
Yeah,
folks
for
here
sure.
too.
That's a great, it's a great place to start. And I think, yeah, I think there's a lot of indications that just from looking at the space that says there's a lot more functional specialties than there used to be, right? In fact, you have you have containers, Kubernetes, right? I mean, in fact, I'll tell you about all the work I don't want to do as a developer. I don't want to understand logging and how to connect my Java logging framework to where it needs to go. I don't want to every time I connect to a database, it takes me a week, right? Authentication, authorization, I'm hopeless. Data masking, haven't so maybe I'll do it someday. secrets management, I finally figured out after like my CI/CD tool leaked my cloud credentials, so I had to figure out how to do that. That's a great idea, but that's not. I managed to kick that can down the road for a couple of years. Uh, oh my gosh, I actually saw a properly written Kubernetes deployment file, and I almost fell out of my chair because it looked nothing like my Kubernetes deployment file. And so each one of these things, I mean, in any significant organization, let's say thousands of developers, you see these functional groups that say, hey, look, you don't have to learn all these things. You can use my library, my shared service, my platform, right? And I will take care of all those things for you, right? So that even at Google, it turns out like there's a group of 5 people at Google that owns the Java platform. And your average, so to liberate developers from having to learn about how to do their Java 8 to Java 11 migration, right? It turns out maybe not that easy, and it changes garbage collection and memory models and all that. This is actually not saying that most developers can't understand it. It's just that they don't want to. If they're like me, they have other things to do than understand all the vagaries of these different JVMs. So anyway, so I think
let me pause you there, because what you're describing sounds an awful lot like, even if it's not formal, and I would imagine that Google does have a formal platform engineering program.
yeah.
Is that what you're talking about there? Is that what you see us moving towards more?
Oh, for sure. And I'm saying,
Yeah.
we have platforms, was like deployment platforms or, the environment container platforms. And I'm saying, if you we can even generalize it further and say there's just a lot of specialization of skills happening. Like, the small, Java group that supports thousands of Java developers at Google. That's an example of a platform capability or a specialization that says, hey, developers, you solve the business problem that you're chartered to do, and we will worry about the intricacies of the Java platform, including the JVM. There's similar capabilities for the build systems, the test systems, the approval, the code review systems, right? All of those are specialties. And I think if we open up the aperture and look over the decades, there are many, 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 many more specialties now than there were a decade ago. Just like there are many more specialties now in the hospital than there were 70 years ago. Does that resonate with you?
It certainly does. So I want to know now, curious minds want to know, Gene,
Yeah.
uh, how the 3 principles, the slowification,
Yeah.
uh, how do teams adopt that?
Yeah.
Is it at
Right.
an individual level? Is it at a
Huh.
team level? Is it at a functional level? Is it at ops level? Where does that stuff come in?
I think the answer is at every level. But let's be clear: the leader is ultimately responsible for allowing and enabling everyone to do the work easily and well. Right? That's a function of the layer 3 social circuitry. And when everyone's stuck, right? When everyone, let me just tell a quick story of like how bad it can get. Um, at Amazon, 2000 in the early 2000s, they were doing say hundreds of deployments a year, back in their late 90s, and because everything was so tightly coupled together, as they added more product categories, they went from books and music to 33 categories at the time, where to get anything done, you had to communicate and coordinate across multiple groups. There was this absurd situation that Werner Vogels, then and current CTO of Amazon, said the digital team. So it was Kindle, music. They had this absurd situation where, in order for a customer to order a product, they had to provide a shipping address. For a digital product, it makes no sense, right? But so they went to the 60 different ordering teams to try to lobby to make a change, and they said we didn't budget for it, and so they were stuck, right? Because everyone had lost that independence of action. And so, another side effect was that you couldn't scale any piece independently. This is what led to that famous memo that said we're going to move to the 2 pizza team, right? So that every team can work and deliver value independently to the customer, right? Without this massive level of communication coordination. And that's what led them to create these microservices, more service-oriented architectures. And so they, went from hundreds to thousands of services, and that's what allowed these teams to work independently of each other. We liberated, thus liberating the teams to work independently of each other. Another key piece was that instead of the dev versus ops silo, where Ops did the deployment. Ops had to be mobilized when things went wrong. They moved to the you build it, you run it. So the feedback went to the right place. And it turns out security, this is a huge boon for security because it means that it's not only you build it, you run it, but you secure it. It's your responsibility. You are the first line of defense. We can act as coach and consultant to help you secure it. And we can even give you tools to do it. So you don't have to make your own seatbelts, right? We can provide you a trusted seatbelt that everyone everyone can use. So this is a great example of simplification. We took a big, intertangled system and split it up to multiple pieces to liberate independence of action. That was enabled by slowification. Jeff Bezos, by putting out this memo, said, "Hey, look, we will do whatever it takes to move to 2 pizza teams." This was a multi-year, allegedly $1 billion plus re-architecture of Amazon. But again, the rewards were huge, right? They were able to go from 10 deployments that mostly didn't finish to 136,000 a day, delivering capabilities at a wild, dizzying rate. And actually, part of that, AWS was born. And then amplification, the need, to put concretely, they found that a whole bunch of troubleshooting was very, very difficult. Like when one service went down, there was often not enough instrumentation to actually say what went wrong. Was it my service? Was it a service I depended upon? Like who gets paged, right? I mean, so they actually had to create much harder boundaries around services. And if you have a 30-minute SLA time and it takes you 7 attempts to page the right group, I mean, you've already blown through your SLA window. Anyway, so how am I doing here?
I think you totally blew it, Gene. No, I love that story, and I appreciate you sharing that. And what I'd like to do, I think we've touched on quite a bit and spoken fairly well to security
Yeah.
in DevOps,
Right.
right? So organizations building stuff that need to have security built in from the get-go. I want to talk about security teams that don't just look after the bespoke stuff, but all the commercial junk that gets tossed on them for communications and supply chain management and I don't know, customer service and
Yeah.
all the things that they bring into the bigger picture.
Yeah.
What can they learn from these same 3 elements that you've applied so eloquently to DevOps?
Oh, that's a great question. Look, I'm gonna try to think my way through the answer. So let me start with like what's often most familiar is so for custom software that you build internally, one of the most powerful things that security can do is embed a security person, into those groups. And it was actually Justin Arbuckle, a mutual friend acquaintance of ours. He was CISO at GE Capital, and he said like one of the best things and breakthroughs that he experienced was having the security people show up to the development stand-ups and the weekly demos. And I was initially mystified by this because my feeling was like it's so informal. It's very different than the kind of heavyweight approvals and kind of the gotcha exercises where you kind of scan a security application, approve it to go into production. And he gave me 2 examples I thought were just phenomenal. He said, this is your opportunity as a security professional to see, oh, hey, look, here's the business goal they're trying to achieve. Oh, hey, they're actually taking, PI, personal identifiable information. Oh, this is a good way to be able to tell them, do you know that once you store that information, you have to protect it? And, there's things that we can do to help you and tools that we can bring to bear. But maybe the best thing to do is actually not store it, like thus obviating that whole surface area of vulnerability and exploit. And I think the aha moment for me was like, oh, instead of this high ceremony handoff process, here's a dialogue we can have that's low stakes, and it really mirrors kind of what friends do when they help each other, as opposed to like high stakes approvals. And maybe that's the kind of level, that's how security can help move the couch, right? Versus, be the inspector at the end saying you moved it all wrong, start all over. So I thought that was just a.
You don't want security sitting on the couch while you're trying to move.
Oh, that's right. Not like that, like this.
No, exactly. No, turn left, turn left.
Yeah.
Yeah.
So that's a great example. Like, amplification is a great example. Just like being a more integral part of the process is where you're valued. I think for like things that are commercial things, I think this is where again security can help because whether it's leveraging processes like, oh hey, here's a standard process that you can use to sort of give to the vendor and have them make sure that they have their SOC 2 review, that we can that we can rely on them for security. So therefore we're not reliant on the security of that, whether it's for the applications or data. Um, if it's not that, then at least giving them, giving whoever wants this tool in a process that they can go through that, we can set expectations that if they do X, Y, and Z, then we can respond with A, B, and C. And I think this just shows that security isn't free, right? I love that. Things in technology in IT is like a puppy. Puppies aren't free. It's not the capital cost that gets you. It's the ongoing maintenance of it that's really expensive. So, these are things that I think, one, show security as a value add, but it also allows people who need to be responsible, we enable them to be better responsible for that.
So we're coming close to the end here, but I want to touch on the social circuitry point. I think it's related to what you just described, but I have a feeling you have a much more succinct point to make specifically around social circuitry, bringing broad security mechanisms throughout the organization. How does that look? Stand-up meetings, yes, but beyond that, do you have any more advice or examples to share where
that's a great question. And I would say instead of a concrete example, let me give you kind of the spectrum of examples. And for me, the spectrum of what interactions look like. And, in software architecture, we call that, coupling and cohesion. And so what we're saying is like when Steve and Gene move a couch, right, they are inherently coupled together. And it means that, if Gene walks off, right, Steve can't do his work, right? And but it's because of their inherent need to communicate and coordinate and co-create. But there's also examples of things when we don't want things coupled together. And so like one example is like air traffic control and pilots in a plane, right? And so in an air traffic controller, right, the controllers can change shifts without permission from the pilots, and pilots can change who's on the radio without permission from the air traffic controllers, because all of the what's important is in the message, not the messenger. They've agreed on protocols, they've agreed on processes and norms, vernacular, and that actually creates independence of action. And so, as a security person, I would say, what things do I need kind of highly coupled behaviors, right? Where you just want the security person to sit side by side with the developer and solve a problem together, right? And you don't want to go through work tickets, you don't want to go through forums or 8 levels of management. Just go up 8 levels and down 8 levels. Just have them sit next to each other and solve a problem together, right? Kind of the ultimate DevSecOps co-creation activity. But there's other things that you don't want security coupled to, right? We don't want every security change and every security test to go through a security engineer, right? Those are things that you want built into the tools so that can happen independent of the security professional, right? Or there's approval forms, right? Where you don't want, I fill out a form and I know that within a week or two, right, I will get a response back, right? So we decoupled security from those functions. And so I think for me, those are just 2 great examples of like, for a security leader, as we design kind of the interactions that we want, where do I want, face-to-face contact? We're working on a problem for a half a day, maybe a week, right? Where you want that security person involved in every step, like in a generative AI project, right? Where, hey, look, we have a common goal. We're going to create our own processes, but security's got to be in the room. Versus, activities where, hey, look, I understand what the inputs are. I understand what the outputs need to be. You do not need to be coupled to me, right? We tell us what you need, and we'll prioritize it, and get it back to you, right? And we have a negotiation about what the SLA windows should be. But this is something that we can do by ourselves. I think that's a really good lens, and I think what went wrong in GRC systems is that we mistook a lot of activities that we thought had to be highly coupled that should not have been coupled at all.
Yeah, interesting point. And I was certain we were gonna take a dive into Gen AI, and we almost made it through without touching on it at all. you mentioned it once there. I think maybe we'll come back and we can have a dedicated conversation to that. Because what I want to do is talk about people sitting on the couch reading the book that you and Steve wrote for them. Um, quickly, tell me, well, not quickly, tell us who you wrote the book for and what you hope they will get from it as they read it. Is it a resource? Is it a thrilling novel? Is it
Yeah.
tell, tell us who it's for and what you hope folks get from it.
Yeah. Oh, that's a great question. In fact, look at the back cover because often, just a little secret between authors. We often use the back cover as a kind of a proxy for who the audience is. So, one person is Paul Gaffney. So he used to run technology for Home Depot, Dick's Sporting Goods. He was a CTO and supply chain head at Kohl's. Anyway, so yeah, a technology leader. One of them is Phil Venables. He was the CISO at Goldman Sachs for I think the longest tenure of any CISO I've ever known, and he's now CISO at Google Cloud. But he was also a former board director for Goldman Sachs Bank. And Dave Silverman, he was one of the co-authors of Team of Teams. Dr. Jeffrey Liker wrote The Toyota Way. So I think, okay, so I'm just sort of reloading in my head. So it's for the technology leader, but also their boss. Right? I think over my journey, I've seen so many things where the success of the technology leader, and that includes security, is so dependent on who their boss is. You change out their boss, and it was this great organization falls apart because they no longer had the person who's setting the tone at the top that was creating the air cover for the technology organization to succeed. And to me, that breaks my heart. So one of the goals of this book is to show that person who the technology function reports to, that these things that leaders need to do is not just for technology. It should be familiar to any person who succeeded in supply chains, manufacturing, engineering. And incidentally, one of the things I'm super proud of is that the foreword was written by Admiral John Richardson. So he used to be in charge of the U.S. naval reactors. So they are comprehensively responsible for all the design and operations of nuclear reactors for every reactor in the seagoing fleet for the U.S. Navy. And he became the chief of naval operations for the entire U.S. Navy. So that's 600,000 sailors and civilians who support them. And so after having left the Navy, he's now on the board of Boeing, at Exelon, the largest operator of nuclear reactors in the U.S., and now green energy. So I'm hoping that this shows that the book is really aimed to show that whether you're a technology leader, I think a lot of these themes will be familiar, but there are universal truths and principles at work here that isn't just technology. It's manufacturing. It's whatever domain that successful leaders come from. It's applicable to them too. This should be familiar to them. Sean, how am I doing?
Yeah, and I was trying to do the math, and I stopped at 2, but I have a feeling others will keep doing the math. 2 being 1, the book you buy for yourself. 2, the book you buy for your boss. But then I'm just thinking, well, there are other leaders that need to understand these things as well to some degree, right? Especially when we start talking about the social circuitry.
Absolutely.
That common understanding and appreciation for what's going on is needed. So perhaps the boss pays it forward and buys it for the whole team, all your peers. But I think the point is, for me, these are concepts that you've studied, you and Steve have studied, have practiced, have guided, and seen in action, right? Good and bad. And yeah, why not learn from somebody who has a lot of information and knowledge like you and Steve? So
I love that. Can I leave with maybe 2 quotes that
yes,
that
please,
remind me of?
absolutely.
Uh, Winston Churchill said, "We shape our buildings, and thereafter they shape us." I mean, it's the same thing with the architecture and the social circuitry of an organization. We create the social circuitry and architecture, and forever after, they shape us, right? And so it's one thing for us to do that within the technology organization. Maybe we can create a little island of happiness and productivity and greatness, but ideally that should fit in, in an overall architecture of greatness, right? So that maybe the organization can learn from technology and get the air cover, right? And therefore we get the air cover that we need. And the last thing that I think has made this project so satisfying to me is they say the goal of science is to explain the most amount of observable phenomena with the fewest number of principles, confirm deeply held intuitions and reveal surprising insights. And that's exactly what this whole creation process has been for me, which is why I find it so intellectually challenging, but so gratifying because, the notion that you can explain the most with the least. And I'm hoping that people will walk away from the book saying, oh, this gives me a language to talk about these things, either why things went right or why things went wrong.
Yeah, and it reminds me of, which I'm often told, write less, be more succinct and to the point. And I think, I think if you can be simple and share that simplicity in a way that others can absorb it, and then share it with others too. I think you've got a winner there. Gene, I could talk to you for hours. I'd definitely love to have you on again, and so we'll make that happen. We got to touch on Gen AI at some point somehow. But until then, I want to thank you for putting that book together with your co-author. Congratulations on that, and I want to thank everybody for joining us for this conversation. I'll put a link into the show notes so people can find your book, so people can find you, and I'll also include the link hesitantly to my co-founders Marco's conversation
Fantastic.
with Steve. I think Steve definitely brings a different perspective than you and I. Marco and Steve bring different perspective than you and I did today, but none, certainly not any less important.
Oh, and highly recommended. I mean, just that was a phenomenal interview, and just to hear Steve talk about it from a different perspective, you will hear you'll see glimpses of why it was so rewarding of a journey for me. So, highly recommended, Sean.
Good job sticking with it to do the hard part.
Yeah. Oh, I just realized we only win if they lose. Never mind. Don't listen to it.
Nice one. Well, Gene, it's a pleasure to see you. Grateful to have you in my circle after all these years, and hope to have you on again soon, and keep well.
Sean, thank you so much for having me on, and looking forward to seeing you again soon. It has been way too long.
It has been. All right. Thank you.
We hope you enjoyed this conversation. If you learned something new and this story made you think, then share ITSPmagazine with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our columns. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.